Hello, mathematicians. Today we're going to be learning about fractions, more specifically about equivalent fractions. So here we have the fraction 1 over 2, and this fraction represents one part out of two equal parts, as we see here in our model. And what we're going to do is we're going to find an equivalent fraction to 1 over 2. And in order to do that, we're going to multiply the numerator and the denominator by the same number. In this case, we're going to use 2, but you could use any number as long as you're multiplying both the numerator and the denominator by that number. So in this case, since we're multiplying by 2, 1 times 2 is equal to 2, and 2 times 2 is equal to 4. And here I also have a model of 2 out of 4. And notice that these models look exactly the same, with the exception that the second one is cut into more parts. But the shaded area is exactly the same for both, and that's what makes these fractions equivalent. And if we want to prove that 2 over 4 is equal to 1 over 2, all we have to do is divide both the numerator and the denominator by 2. So 2 divided by 2 is equal to 1. And 4 divided by 2 is equal to 2. And notice again that this model is the same, except it's split into less parts. But the shaded part for all of these is exactly the same. Here we have 1 over 2 again, and this time we're going to multiply the numerator and the denominator by 3, so we could see what that looks like. So if we multiply 1 times 3, that is equal to 3, and 2 times 3 is equal to 6. So 1 over 2 is equal to 3 over 6. If we take a look at our model, notice that even though our second model is cut into 6 pieces, 3 out of the 6 is equivalent to 1 out of the 2 in our first model. And that's what it means to be equivalent fractions. Even though these values look different, it's still the same fraction. Essentially, it's like cutting a cake. If we took a cake and cut it directly down the middle, one out of those two parts would be equivalent to if we had a cake that was cut into 6 pieces and we had 3 of those 6 pieces. The value is the same, just the parts are a little smaller. And so if we take 3 over 6, and divide the numerator and the denominator by 3, notice that 3 divided by 3 is equal to 1, and 6 divided by 3 is equal to 2, so we come back to that original fraction. So these two fractions are equivalent to each other, and let's take 1 over 2, and now multiply it by a different number to see what happens. So if we multiply the numerator and the denominator by 4, 1 times 4 is equal to 4, and 2 times 4 is equal to 8. So 1 over 2 is also equal to 4 over 8. And so if we look at our model here, notice that our slices, these portions, are getting smaller, so it's going to take more to equal the 1 out of 2 that we originally had. So essentially, it's like cutting this cake into smaller pieces. So in this case, 4 of those pieces would be equal to 1 of the 2 equal parts. And then if we take 4 over 8 and divide those both by 4, 4 divided by 4 is equal to 1, and 8 divided by 4 is equal to 2, just proving that these two are equal. Now let's use a different fraction as our example. So here we have 2 over 3, and in order to find an equivalent fraction, we have to multiply the numerator and the denominator by the same number. So let's go ahead and multiply them by 2. So 2 times 2 is equal to 4, and 3 times 2 is equal to 6. So that means that 2 over 3 is equal to 4 over 6. And if we look at these two models side by side, we could see that the shaded portion is the same, but the one to the right is just cut up into smaller pieces, but these two fractions are equivalent. And now if we did take 4 over 6 and wanted to prove that it is equal to 2 over 3, what we could do is divide the numerator and the denominator by 2. So 4 divided by 2 is equal to 2, and 6 divided by 2 is equal to 3. So yes, these two fractions are equivalent. Let's go ahead and multiply by a different number. So we're going to take 2/3 again, and this time multiply it by 3. So 2 times 3 is equal to 6, and 3 times 3 is equal to 9, which means that 2 over 3 is equal to 6 over 9. And then if we want to prove that 6 over 9 is equal to 2/3, we're going to go ahead and divide them both by 3. So 6 divided by 3 is equal to 2, and 9 divided by 3 is equal to 3. So these two are equal. All right, so let's take 2 over 3 again, and this time multiply it by 4. So 2 times 4 is equal to 8, and 3 times 4 is equal to 12. And again, look at our models. The amount that's shaded is exactly the same. So these two fractions are in fact equal. And if we did want to prove it, we would take 8 over 12, divide 8 and 12 divided by 4. And 8 divided by 4 is equal to 2, and 12 divided by 4 is equal to 3. So if we want to find equivalent fractions, we either have to multiply the numerator and the denominator by the same number, or divide them by the same number as long as both of those numbers are divisible by the number we're dividing by. All right, let's take a look at these two fractions. So we have 2 over 6 and 3 over 9. If we look at our models, we could tell that these are equivalent, but we don't really have a number we could multiply 2 over 6 by to get 3 over 9. And we don't have a number we could divide the numerator and the denominator by to get 2 over 6 from 3 over 9. So we could take a look at these two fractions and try to simplify them. So if we take a look at 2 over 6, we know that we could divide 2 and 6 by 2. So 2 divided by 2 is equal to 1, and 6 divided by 2 is equal to 3. So that means that 2 over 6 is equal to 1 over 3. Now let's take 3 over 9 and think about what number we could divide both of these by. So a number that we could divide 3 and 9 by is 3. So 3 divided by 3 is equal to 1. And 9 divided by 3 is equal to 3. So even though we weren't able to get from 2 over 6 to 3 over 9 or vice versa, once we simplified both fractions, we see that they're both equal to 1 over 3, meaning that they're also both equal to each other. And that's it.